So we're starting with the most missed question up until the least missed question. So if we get to the end and I have talked too long and we don't cover something, it's the ones that most people got right. So that's why I like to do it this way. So you're going to be flipping around where you are. As far as your sheet that you're going to turn in as a quiz grade, I need it numbered very well so that when I'm going through your paper, I'm literally going problem 1, problem 2, problem 3. Like I can count that you have all 40 problems with something written down. So like you're going to write down number 30 right now. So on your notebook paper, you're writing down number 30. And now you are taking notes to go along with what we're doing. Remember, you're going to take another multiple choice next week that counts as a grade, like correctness grade. So we're structuring this to help you with that, but also it should cover a lot of stuff that's going to help you for the AP exam. So like, yes, I'm giving you a grade for this, but you should be doing a good job on this for more than just the grade. Okay, so I'm going to kind of talk about what I think about the problems too. I think this is a very easy problem. This is the most missed question on our test. This is an easy problem. This is a hard concept to get to the fact that it's an easy problem. Like you get lost in the wording to get to the fact that it's an easy problem. I am not concerned with the fact that so many people missed this one. Another thing is, like, I mark all over my paper anytime I'm going over a problem. Like I only wrote on 2 problems on this sheet, and like I've got circles off to the side writing on both of those 2 problems. I would definitely recommend getting in the habit of that. It helps a whole lot. So delivery service places packages into large containers before flying them across the country. Filled containers vary greatly in weight. Okay. Suppose the delivery services airplanes always transport 2 such containers on each flight. The 2 containers are chosen so that their combined weight is close to but does not exceed some specified weight limit. Random sample of flights with these containers is taken and the weight of each of the 2 containers is recorded. So the weight of these 2 containers is something. Well, all of these problems are talking about what? Correlation. So use the answer choices to help give you a direction. We know I'm dealing with correlation. Okay, so again, I go off topic a lot here. So correlation means what? R. What do I know about my values of R? And they can be between, so yeah, they can be between what and what, and then we'll talk through that, what you just said. What's the lowest it can be? 2. And then so, somewhere around here, you said is weak. Out here, these are strong. And then, so it's how strong it is. R tells us only linear relationship. It tells us how strong it is and what the direction is. So what it's asking us is direction or strength. Strength. It says 0, negative, positive, 1, or we don't know. So we need to know if we're here, if we're here, if we're here, or if we're here. All this is background. Let's think if A and B have a negative if A and B have a negative R, what does that mean?
Negative slope.
Which means as A, then now this is a very easy problem, but we're still not to the point where it's an easy problem yet. This is the wording that I think is confusing here. the weights of two containers are on the same flight. Let me erase stuff. So I've got container 1, container 2, and just for the record, I am going to record every single one of my classes and then post all of them online because y'all be at different places. So I want to keep the classes at the same spot. So if I ever say something in your class and you start to write something down and you were like, I was writing really quick, but I wanted to go back to that, I'm literally going to post every single video for the next 3 or 4 days. Well, this would be like flight 1, flight 2, so forth. I know that these two have to do what? Have to be under some specific weight. So let's just make up a number. Let's make up something easy. Let's say their total weight has to be 100. All right, so if container 1 is 30, what's the most container 2 can be? If container 1 is 50, what's the most that container 2 can be? If container 1 is 60, what's the most that container 2 can be? So as these increase, these do what? So conceptually, this is an easy problem, but the wording doesn't send you directly to what I just drew, and it's confusing to get there. So it's very easy at that point. If I would have drawn you that, you can see that as the amount of the size of container 1 gets bigger, container 2 gets smaller, which means there's a what kind of correlation? I think wording of that problem was unnecessary. But you should be able to at least feel okay with following me. And now at any point, like I said, I'm doing this as a structure to review. At any point, if you have questions about what I say or anything relating to what I say, just stop me there. Yeah. What if it's reversed then? So then still, if I wrote it the other way, if I said container 2 is 70, container 1 is 30. Container 2 is 50, container 1 is 50. So these get low, these get high. So they go different directions instead of going the same. Whereas like your height and your weight, as you get taller, you're going to weigh more. That would be positive. So that's serious.
We can write on the axis.
Yes, yeah. And now, I'll probably, actually, I might not take them back now. It might be easier for y'all to keep up with them now. So yes, you can write all over your test or paper or whatever. I don't care. But just realize I'm not going to go through your test individually to see if you write notes. I'm just going to do that. All right, so 34. This one I was kind of concerned with. And once I show you this, you're going to be okay with it. So, researcher has conducted a survey using a simple random sample of 50 registered voters. Well, just by habit, simple random sample, that's my N. We're doing a confidence interval. I definitely want to look at the fact that, hey, this is a proportion. Assume that sample proportion does not change. And I'll come back to what that means, why they said that. Which of the following best describes the anticipated effect on the width of the confidence interval if the researcher were to survey a random sample of 200 rather than 50 registered voters? Don't write this with me because I don't want you to deter from this. Let's write my equation in general for confidence interval for proportion. What does it start with? P what? Look at your orange. Now that we have the orange, I'll refer to it. In general, a lot of these are on there. I think this one's maybe on the back. Square root of what?
P1.
But so that the back gives it to us as a 2 sample, but we can use that to remember what this is. P hat
1 minus 1 over.
Now, the only thing we are changing is what? In this problem, it's asking us the only thing we're changing is what? It says, what if we were to survey 200 instead of 50? So that's the only thing that changes. So, the reason it said assume the sample portion does not change is that means, hey, don't worry about this, don't worry about this, don't worry about this, our z is not going to change either. And that's the reason it said that. So, I've got my original and my new. So, originally, my n was what? My new n is so the part that contained n, I don't need to worry about any of this on the top, so I'm just going to call it 1. So this is something over 50, all under a square root, which means what am I going to write here? Alright, so let's say I still haven't made any connections yet. Let's just type those numbers in. When you do square root of, is everybody okay with why I did 1? Like I can plug numbers in, but I have to plug the same numbers in, so I'm just going to use something easy and just say, I'm not going to worry about that part. So what's 1 square root of 1 over 50?
0.1414.
What is the square root of 1 over 200?
107.
So this is what we started out with. This is what we got. So what did it do?
Gonna look the width.
Did it get bigger or smaller?
Hey, what does it say next to it? Like, what is under that?
Here?
Right, like.
Oh, I started right equation.
Oh, okay.
So Maria, this is the whole. You take the whole thing now, right?
Yeah.
I'm just gonna hand you everything back. I'll still need you to type in your answers eventually, but for right now, so you don't have to get behind. Okay, so let's now take a step back and say I'm looking at this problem and I had no freaking clue where to start. What happened to my sample size? It increased. As my sample size increases, and this is what I would consider the big topic out of this. As your sample size increases, you should always know this. What happens? Which is talking generally about the width, spread, anything like that, is going to what? And that is one thing that you have to know, and getting back to that concept happened at least twice in the first 10 questions I went over. As your sample size increases, your spread decreases. Same thing opposite. So if I'm just saying I don't know where to start this problem, but I can look at that. My new one is definitely going to be less. So a fourth, a half, the same, nope, twice, nope, 4 times, nope. I've at least narrowed it down to 2. So I'm going to talk about problems of, hey, this is the way you should go, or this is the way you should at least go. Now, the other thing here, this is something we went over, because it's in the bottom of a square root. Remember, this was, our sample size was times 4, which means our spread was that, which we've talked about before. If you multiply your sample size by 4, you divide your spread by the square root of what you multiply by. And at that point in time, a bunch of you were okay with this. but it's been a couple months and you don't remember that. And that's why I'm not starting there and I'm thinking, okay, let's just think through it. All right, number 21.
I have a question. So if your sample size decreases, then you just do the opposite.
Right. Yeah, so her question is if the sample size decreases, yes, you'll just do the opposite. So if your sample size decreases, your spread's gonna get higher. Which means you divide by yes.
And what is the confidence level after that?
So the confidence level would that problem said nothing, it's saying nothing else
But
changed.
just for future.
So your confidence, so question was if the confidence level changes, it's just that this would change, so it's almost like changing the multiplier. So if it went from 90 to 95, this is gonna be a bigger number, which means your spread's gonna be higher. So that part is direct because it's not in the bottom of a fraction. But yeah, yes,
Is the spread being decreased because it's getting like more normal?
because it's the idea that it's getting closer to normal, yeah. Yes, that is another thing to think about. Alright, so 21, a little bit concerned that this was problem number 3. Mutually exclusive outcomes. Okay, so that's what it means to be mutually exclusive, because they don't overlap. You can't be both at the same time. So let's go easy ones. If they are mutually exclusive, can I be both at the same time? No. So is the probability of A and B 0?
Yes.
I can't be both at the same time, so the probability of me getting both at the same time is 0. Part 3. Probability of B or C is probability of B plus probability of C. Is that true or false? Let's look at our orange sheet. This one's somewhere on your orange sheet, kind of. Now, don't write what I'm writing right now. Alright, so that's a little bit different. But what do we know about these two things? We just talked about it. It's 0, so we didn't have to write it. So is it true that B or C is probability B plus probability C? That one you really, really, really need to know. That one concerns me the most. So if two things are, if they're not mutually exclusive, then you say probability of A or B equals probability of A plus probability of B minus probability of A and B, which is what it says in your equation sheet. It's just this if they are mutually exclusive, because that end part is 0. And that's one thing that you need to know. Yes. And I could make that one use. Alright, so the only thing I haven't talked about yet is this one, which this is the one, like, these I need you to know. This one, I would see if somebody, before we really reviewed it, and you just come in here on a day where you haven't looked at anything, maybe you weren't thinking through this one. So, how do I check if problems are independent? And let me go with C just because of what it says up there instead. A and C are independent. Okay, give me something. Which one? Because these two things are the same. Right? We're checking the probability of A. We're checking the probability of A. It's just here it's under a condition. Alright, so if I know that I am in C, what is the probability that I'm A? And what is the probability of A? Not 0. That's something that you will definitely expect to see on the AP exam again. This part. But like I said, on this one, when you haven't looked at anything in a while, I could see where that's the one people would miss.
Why is two it's added together? Oh, because
Okay.
it's like very.
And 6 at the same time.
It doesn't include it.
Right. So now our answer is just what? Wait, are they independent? So our answer is D. Wait a minute. I think I wrote that one. Because if I am in this circle, what's the probability that I'm in that circle? And that's what that's saying. That's the way to think through what that's saying.
That makes more sense.
Alright, now this one, I don't know how to feel about this one. I don't need to explain much to tell you this problem. There's not much writing that could be in this problem. It's pretty much you either know it or you don't. I guess I'm kind of concerned that it's this high, but it's not uncommon that people, when they haven't looked at them all, don't think through it this way. Alright, how do you find it conceptually? How do you find the mean? Add them all up and divide by how many there are. So if I have a group over here of things that I added up and divided by how many there were, and a group of things over here that I added up and divided by how many things there were, could I physically put those two things together and add up how much there is total still? Could I do that part? Yes. Could I still divide by how many there are, so I knew how many were here and how many were here? So could I do that with means? Yes. I need no extra information to do that. I have to do, so like it would be, so to find X bar of sample 1, you added them all up and divided by your sample size, which was 21, and you got 42.6. So I could work that backwards to figure out what my total was that I added up, do the same thing for this one, and kind of do that whole process again. Now, our process, like very, very general conception wise, how do I find median?
Middle number.
Median.
Middle value.
Middle number. So if I have the middle number of this set, and I know nothing else, and I have the middle number of this set, and I know nothing else, when I put them together, will I know where that middle is? No. So you cannot do that with median, but you can with mean. And that's all I need to do to explain. Like you just need to know that. So you cannot, if you combine samples without knowing all of the individual values, you cannot find median, but we could find mean.
How could it be these?
Okay, so I'm just going to do 3 numbers. So if this is, I don't want to think that way. This is your equation to find mean. That's a good thing to write too. So this is your equation Wait, which one is the correct equation for finding mean?
Let's see.
And maybe some of you just looked at it and thought mean and didn't think median. And I'm not surprised why this is missed a lot. But if you see it again, don't miss it.
So you need like a data set to find the mean?
Yeah, you would literally have to have all of the values to be able to do median, but not for me. And again, any side questions you have, just stop me. It's the number 12. This is one that I'm not surprised a lot of people miss it, but you need to know. I like to structure things so x is normal, y is also normal, and then it gives us mean and standard deviation of each. Alright, so the mean of x is what? The standard deviation of x, mean of y, standard deviation of y. And it wants us to do y minus x. So how do I find the mean of y minus x? This is the one that's obvious. I just take the mean of y minus the mean of x. What is the mean of y? Minus 10, which is, so I have at least narrowed that down. This is not usually the issue, this is the issue. Combining two random variables finding standard deviation always has two rules. What is one of the two rules? Combining the standard variances. Well, what does variance mean as opposed to standard deviation? Squared. And what's my other thing? Always add. You don't, if I am this far away and I'm this far away, I'm not all of a sudden closer when I put them together. So I'm writing this one as sigma of y minus x equals, well, to do it as variances, I do squared. So I'm writing out the equation symbols and numbers. So I take sigma of y squared because it's variance. I always add, so I add in between. Then I take my sigma of x squared. But what do I need to do now? Square root it to get it back to a standard deviation. So sigma y was 4. 4 squared plus 3 squared. Well, that's 16 plus 9, which is 25. Square root of 25 is 5. Pretty much in all situations, mean does exactly what you would think it would do across the board for our entire class, but not standard deviation. Yeah, so the answer is C. And I'm bad about that, not actually going and telling you it, like making sure I actually clearly say this is the answer, so stop me if I don't.
Basically, measures have a negative state.
Correct. You can't, like, it's how, standard deviation is how far away you are from something. It doesn't tell you where you are in relation to it, so how far you are away has to be constant. Now this one, I actually wrote on my paper that I'm genuinely concerned. Because you will see what we're about to talk about on the AP exam. I can almost guarantee it. So the fact that it was the 6 most missed questions were irrelevant. And now the question itself isn't set up the way I think it'll be on the AP exam, but it's dealing with the concept. Alright, so I want to start here tomorrow as far as concept, but I want to finish this one now as far as what I'm concerned about. So this part, I don't want to shorthand myself on this one, and we have 3 minutes. What are our 3 different sampling, or what are some of our, we've got stratified, we've got what else?
Okay, Lane.
And one more.
Systematic.
Alright, so I want to have this conversation tomorrow, but one of these definitions, or one of these answer choices is basically the definition of one of these 4, and that's where I think you will see it on your AP exam. Do you know which one it is? That is not, as far as this question, it actually says which of the following is not a characteristic of this, so that actually is the answer, because it's this. But I want to talk about all 4 of these and like the difference between them and stuff. Like I want to start here tomorrow, but I expect you to see this definition of some sort on the AP exam. You need to know that simple random sample is every single possible combination of n is equally likely. Alright, so let's just stop there today. I definitely don't want to stop in the middle of the topic I really want to talk about.